Hey, Calc 1 class, this is Mr. Blevins, and I am going to kind of review with you guys the difference quotient and what the difference quotient is. So, if you recall from pre-cal, this guy right here is the difference quotient. So it is f of x plus h minus f of x all over h. So what is the difference quotient? Let's quickly review that so we can use it for a problem like this. So this is our function, this is our y equals some function of x, and all that means is to get y we do something to x. And that f of x can be anything, a trig function, it can be any of the functions you learned in 171 or 172, pre-cal 1 and 2. This is our f of x, our 1 minus 4x squared. So that's, excuse me, that's this guy right here, 1 minus 4x squared. And that's what the graph I'm looking at right here. This is 1 minus 4x squared. Now notice the y-axis is growing much quicker than the x-axis. Okay, so the scaling is adjusted for this. All right, but this is, call this x. Now this is specifically 4 because of the problem that we're doing, the example I'm doing, but let's just say that this is x. And x is just some number on the number line. Okay, and then we move over from x, we move over h units, we add some number to x, and then we end up over here at x plus h. What that means is this little gap between these two numbers, which is 2, if you're actually, you're not looking at general variables, but this distance between these two numbers is what we're calling h. So h is this distance between the leftmost number and the rightmost number. All right, and we use h in this scenario because it means horizontal. The h stands for horizontal, a horizontal shift, a horizontal distance between one number and the next. All right, and then remember, how do you get a y-coordinate? You do something to x. So what do I do to this x coordinate? I plug it into the function and I get this y coordinate. So down here, this distance right here is f of x. Okay, and then this green distance, I've moved over h units. I plug this number into the function and I get this coordinate out, which corresponds to f of x plus h, which again would be this guy right here, that y coordinate. Okay, so x plus h, f of x plus h. Okay, now the black line, this is where the actual difference quotient comes from. The coordinates of this point right here is x f of x. Remember, that's the y coordinate, x, y, f of x. So x, f of x, that's the coordinate of that point. All right, and then the coordinates of this other point would be x plus h, comma, f of x plus h. That's the y coordinate that goes with it. All right, so we've got 2 points here, and if you have 2 points, you can find the slope between those 2 points. So what's the slope between these 2 points? Well, we're just going to plug the coordinates of those 2 points into the slope formula, and we'll get the difference quotient. So the slope, remember, that's y2 minus y1 over x2 minus x1. Well, what's y2 and y1 here? y2 is this f of x plus h, minus y1 is f of x. x2, x1, it's x plus h minus x. And if I subtract x from x plus h, the x's cancel, and I'm simply left with just the h. And that's the difference quotient. It's simply slope. It's the slope between 2 points in the graph of a function, where h, again, is that horizontal distance between the 2 points, not the distance between the 2 points, straight line distance, but the horizontal distance between the 2 points. So that's what this h stands for here. It's very important that you understand that, so you'll be able to understand what happens when h goes to 0 going forward. That's what's going to happen as we work through this example, is this h, this horizontal distance, is going to shrink down to nothing. Alright, and that's the whole gist of the problem. So we want to find the slope of the curve at a particular point, at a single point. So what's the slope here? So what we're going to do is we're going to plug these two things into the difference quotient, and we are going to allow h to make its way to 0. Alright, so let's visualize it. Okay, I widened our window a little bit so we could see the graph in here. And here is h. H is that horizontal distance between these 2 points on the graph. Again, that's the blue dashed line, the vertical line, that's the f of x. This is the f of x plus h. Alright, here's h. Here's the slope of this black line, is our difference quotient. And again, as h goes to 0, what's happening here? Well, that purple line, you can't really see it. This is purple up here. Let me just show you so you can see it. This on top of the line here, that's purple. Okay, that's the h that I'm talking about. It's making its way towards 0. Well, these 2 points are getting closer together, and they get closer and closer and closer together. And we can see that that black line, its slope begins to change until it finally gets right up against it, and it's virtually now just the h is 0.01. These two points have converged on top of one another. They're basically the exact same point right now. Now, if we zoomed in enough, there'd be a gap, okay? But way out here at what we were looking at before, we can't tell that those are two different points. H has shrunk and made its way towards 0. Now, h can't be 0 in the difference quotient because it causes division by 0, but it is making its way towards 0. And we're basically getting a single point and a slope at a single point. That's the idea of instantaneous rate of change. The slope of this line, this black line, at any time is called the average rate of change. It's the slope between 2 points on the curve. But the instantaneous rate of change is when those 2 points converge and become a single point. And now we get what we call a tangent line instead of a secant line. It's not going through 2 points. It's going through basically just a single point. It's just nipping the curve and not touching it again locally here. We're just now tangent to the curve rather than, again, a secant going through 2 points on the curve. Alright, so how do we do it? Well, a reminder, it takes a lot of algebra to do calculus, especially in the beginning. We have to understand function notation. We have to understand our function takes the x-coordinate, it squares it, multiplies it by 4, and then it subtracts that from 1 to get the y-coordinate. Well, if this is now my input, what is the function going to do? Well, it's going to square that. It's going to multiply that by 4, and then it's going to subtract that from 1. This is f of x plus h. If I put x plus h into the function, it's basically just replacing the x with x plus h. Now, we always, when we're going to do these problems, we always need to expand this out and then simplify this. So 1 minus, let's square out the x plus h squared. So remember, x plus h squared is not x squared plus h squared. You got to FOIL it out. It's x plus h times itself. Remember, that's what square means. So we end up with 1 minus 4. I'm going to put a little bracket now as I'm squaring this out. X times x is x squared. X times h is xh. H times x is another xh, so that's 2xh. and then h times h is h squared. So we do get the x squared and the h squared. We also get this extra 2x plus h term in the middle. Now distribute the negative 4 through, and you've got 1 minus 4x squared. Right, minus positive 2, minus 4 positive 2 would be a minus 8, minus 8 xh. And then minus 4 times h squared will be a minus 4h squared. Alright, so what we're going to do is we're going to replace f of x plus h in this formula with this. This is what f of x plus h is. Okay? This is f of x. Alright, y is the same thing as f of x. And then those two guys are both over top of h. So I'm going to switch to black here. F of x plus h is this thing. So I'm going to just call this the difference quotient. F of x plus h is this, so I'm going to rewrite that. Alright, minus f of x. So that's going to be minus this thing. So minus parentheses 1 minus 4x squared. 4x squared all over h. Okay, and now distribute this minus 1 through. You're going to get 1 minus 4x squared minus 8xh minus 4h squared minus 1. Negative times a negative is a positive 4x squared, still all over h. Okay, now do you see what's going to happen here? The 1 and the minus 1, they cancel. The negative 4x squared, the positive 4x squared, they cancel. In the difference quotient for a polynomial function, the minus f of x should always cancel away when you do the expansion of the f of x plus h like that. So I'm left with the difference quotient being equal to negative 8xh minus 4h squared all over h. And notice these both have h's in it. So I'm going to pull out that common h. I'll be left with as a negative 8x. I'll be left with a positive, okay, because I'm factoring out a negative. I'm sorry. I'm not factoring out a negative. I'm just pulling the h out. I was thinking I was pulling the negative out. I'll be left with a minus. If I pull the h out, I'll have 4h to the first power, and then over top of h. The h's cancel, and so I'm left with negative 8x minus 4h. Alright, so there's the difference quotient. And again, you did something similar to this in Pre-Cal 1. I'll post some videos, just kind of remind you how to do some of these on Moodle, just for review. Now, what we want to do in this problem is we want to find the instantaneous rate of change. So the slope of the curve at 4, negative 63, that's the same thing as asking, what's the instantaneous rate of change? What's the slope of this line if we shrink this thing all the way down to 0? What's the slope of the line once this h is allowed to go to 0? Well, before, h couldn't be 0 because we would divide by 0 if we allowed h to be 0 in this thing. But once you go through this process that we went through of expanding f of x plus h, plugging everything into the formula, simplifying, the h on the bottom divides out right here. And when h goes to 0 now, it's fine. We don't divide by 0. So what we have to do to answer this question, what is the slope of the tangent line at this point? This is our x from that goes into the formula, and h is going to end up being 0 because it's instantaneous. And the slope at a point, at a single point, there's not 2 points, there's only one. So we're going to allow h to be 0 and x to be 4 in this formula. So if x is 4, we're going to get negative 8 times 4. If h is 0, we're going to have a minus 4 times 0, which is always going to go to 0. So this becomes our slope at that point. Alright, so we end up with the first part of this thing, the slope is 32. Or negative 32. Okay. And then the second part says, what's the excuse me, what's the equation for the tangent line? Well, the nice thing about this is the difference quotient gives us a slope. That's what it is. It is a slope. The difference quotient is giving a slope. So all we have to do is plug in our slope along with the point that they give us. They're giving us a point, they're calling it P up here, into the point slope formula. And if you don't remember the point slope formula, that's something again you'll need to know going forward for calculus. We use it a lot for tangent lines. But point slope is y minus any y coordinate on the line is equal to m times x minus the x coordinate that went with that y coordinate. And so we're going to plug in the points. So we know here we got y minus the y coordinate, negative 63 is a y coordinate. So y minus negative 63 would be y plus 63 is equal to m. We just found m to be negative 32. So negative 32 times x minus the x coordinate was 4. Alright, now we're going to want you to type this in the standard formula. So you'll need to distribute that negative 32 through and then add the 63, or sorry, subtract the 63 from both sides to make sure that you get it in the standard mx plus b version that you're familiar with. So y plus 63, negative 32x, and then negative 32 times 4 is going to be a positive 128. And then we're going to subtract the 63 from both sides. 63. So y is equal to negative 32x. And then 128 minus 63 is going to be positive 65. So there is our tangent line slope to this thing. Alright, and this is just my math lab. I just did a screen grab of a question. Here's my math lab's version. You can also check this stuff on Desmos. It's really important that you understand how to do this and visualize what you're doing. So what we just said is when h goes to 0 here, when we take this limit and h goes to 0, then this black line that we get is the one that we just came up with in that problem, which is equal to y equals negative 32x plus 65. And you can see now that that green line is that black line. So there's that green line is what the tangent line is at that point. And the black line becomes the green line as h makes its way towards 0. So you're going to see problems in your homework sometimes that say find the slope of the tangent line using something called the limit that you'll learn about in the next couple sections. The limit of the secant lines. And so you're going to find the secant line slope like here at 2, and then maybe the secant line slope at 1, and then the secant line slope at 1/2, and then 1/10, and 1/4, and all the way down to 0. And then once you get to 0 again, it becomes a tangent line. And we will eventually give a name to that tangent line slope. It's got a very, very important name for Calculus 1. But that's another few weeks away.